right, welcome. This next lesson is on ellipses, our next conic section. So why we care about ellipses, one big application is planetary orbits. Planets largely orbit in ellipses, not circles. Some planets orbit closer to circles than others. Earth's orbit is pretty close to a circle, but they are all in ellipses. First, our conic definition. Circles we've already talked about. It's the shape we get when we intersect a plane and a cone parallel to the base. An ellipse is the shape we get when the plane is not parallel, but doesn't go through the base. A circle is actually a special kind of ellipse. Now let's talk about the geometric definitions. So a circle is all of the points that are a fixed distance away from one point, which I can get using this push pin and a string. And I just pull it tight and I draw where the string guides me. And we'll take a couple of passes, but this is roughly a circle. Couple extra attempts, but here we have a rough approximation of a circle. Now, what happens if I want two endpoints that are fixed instead of just one? So I'll use two push pins tied to a string, and I keep the string length the same. So let's grab a new sheet of paper, and I'm just going to push these pins in. And then with this marker, I'll pull the string tight and I'll draw where it lets me. So you see I have a little issue with the pins wanting to fall out. And then we'll move to below, and I'm going to keep going and repeat the process. And we get this oval type shape. It's almost a circle, but as we can see, it's a little wider than it is tall. So it's not a uniform circle. We don't have one fixed distance. Instead, if we measure from those 2 points where the pins were, I'll call this one D1 and D2, to any point on the shape, the sum of those two distances should always be equal. So here we have D1 plus D2 is equal to F1 plus F2. And it doesn't matter where we go in the circle, this should always be true. As opposed to a circle, where because we only had the one end point from our center, every point on the circle is the same distance away. That distance is called the radius. This new figure is called an ellipse. All right, so let's write out that geometric definition. It's roughly a stretched out circle. A point xy is on the ellipse if the sum is of the distances from the two focal points is always constant. So in this picture, D1 and D2 that go up to the red point should be the same as G1 plus G2. And it doesn't matter where on the ellipse we are. I can draw any point, and the sum of those two distances is the same. And here's another point. The sum of these two distances is the same. All right, so the equation of an ellipse. It is roughly a circle just stretched out. So instead of having x squared plus y squared equals the radius, we've got this a squared and b squared. A squared is kind of our radius in the x direction, and b squared is kind of our radius in the y direction. And it'll tell us the major and the minor axis length. That's kind of our big diameter and little diameter. So let's sketch one. x squared over 16 plus y squared over 9 equals 1. It's important that it always equals 1. But that 16 tells us our radius in the x direction is 4. And the 9 tells us our radius in the y direction is 3. So I'll start at 0, 0. I'll go left and right 4, but I'll only go up and down 3. And then we'll draw our rough ellipse. All right, so a little vocabulary. There's a couple of special names for each points. The two foci, where those push pins went in, those are called the focus points. Those define an ellipse. The center is the midpoint of the two foci. For this lesson, it will always be 0, 0. The major axis is the longer of the two axes. It's the big diameter. The two foci are always on the major axis. The minor axis is the shorter of the two axes, the short diameter. The vertex, the two vertices are the endpoints of the major axis, and the co-vertices are the endpoints of the minor axis. We'll go through here a couple of examples and identify those as we sketch. And so again, here's an ellipse with all of our parts labeled. We've got the major axis in red, the minor axis in purple. The two foci, the focus points, lay along the major axis, which has our endpoints are the vertices, the two vertices, and the purple, the minor axis, the endpoints are the two co-vertices. One last thing about the foci. If we ever need to find exactly where they are, we can find them using this equation, c squared equals a squared minus b squared, kind of an offshoot of the Pythagorean theorem. So c squared, or c, will be the location of the foci, a and b will be the location of the vertices and the co-vertices, respectively. It's important to always make sure that we start with the bigger than the smaller. So here we'll sketch, and then we'll label all of our parts. 4 tells us our axis in the y direction is 2. Our radius in the y direction is 2. 9 tells us our radius in the y direction is 3. So I'll go left and right 2. I'll go up and down 3. And I'll sketch my ellipse. But now I'd like to find the two focus points. I'd like to find the two foci. So this is laid out vertically. It's taller than it is short. So the two foci should be on the y-axis somewhere. Let's figure out exactly where. So again, we have that equation, c squared equals a squared minus b squared. A squared is already given to us as 9. B squared is already given to us as 4. So c is going to equal the square root of 5. 9 minus 4 is 5. And this is roughly 2.2-ish. So we'll do our best approximation on the graph, and we'll sketch those 2 points, up and down 2.2-ish. So now let's label everything. That at the top of our ellipse is the vertex, and on the left-hand side and on the right-hand side, we have the two co-vertex points. Our center is here at 0, 0. And those 2 points we found using C, those are the foci, or the focus points. All right, let's do a couple other examples. So for this next one, we want to rewrite. Ellipses aren't always given in standard form, so we need to do our best to change it into standard form. Big difference is it's not equal to 1. So if we have 25x squared plus 9y squared equals 225, I just need to divide everything by 225. That'll get the right-hand side equal to 1, and we'll see how the left-hand side simplifies. 25 over 225 simplifies to over 9. 9 over 225 simplifies to over 25. And on the right-hand side, we have 1. So we have standard form, tells us our radius in the x and y direction. It's 3 units wide, or 3 units left and right for a radius, 5 units up and down for a radius. So it's roughly going to look like this. So again, thanks for watching. Please let me know if you have any questions. The worksheet is at the end of the notes.